to get ready to kick off the final presentation of the day here. And believe me when I tell you we've saved the best for last. I think this is going to be super cool. We've got Ian and Ryan here from Branch Metrics, and they're going to talk about scaling their business and how when they were faced with that hockey stick growth that we all hope for, how they were able to achieve that using DynamoDB. And so with that, I'm going to get out of the way and let these guys do their thing.
All right, thanks everybody for having us today. We're going to be talking about scaling from 0 to billions on DynamoDB, and I'll talk a little bit more about what I mean by that. Just to go over what we're going to cover, a high level of what Branch is. I think the context of our company and our product is very relevant to the talk about Dynamo. We're going to talk about our scaling challenges with some nice music in the background as well. Thank you very much for that. Is this coming from my machine? All right, cool. Well, I'll keep talking over the music as long as you don't mind. We're going to talk a little bit about applications of Dynamo at high production scale. And since we've been using Dynamo in production for a year, we're going to talk about some of the lessons learned from there and some key takeaways as well. Ideally, we're going to try to do all of the QA at the end. So we left some time at the end, but feel free to queue them up. Cool. So just at a high level, because I know there's a pretty diverse audience here, a summary of the key takeaways and the messages that we're going to try to leave for you. For founders and CTOs, we're going to talk about some of the evaluation frameworks that we use to actually make some of these technical decisions, whether you're a one-person startup or a 300-person startup. Choosing a data store like Dynamo is an extremely critical decision. So we're going to talk through the decision process that we made through that. If you're an engineer, a developer just hacking on AWS, you're going to get introduced, exposed to DynamoDB, maybe get some ideas, and then play around with it later on. And for everybody else, Branch has been a crazy, wild ride of a startup. You'll learn a little bit of the lessons about what we've experienced there. Cool. Yeah, just quick about myself. I'm the director of engineering at Branch. I've been with Branch for about 4 years. The company is only 5 years old, so I've seen a lot of craziness. Prior to Branch, I was managing some of the ads and analytics teams at Twitter. And with me today is Ryan. He's on our platform engineering team. And he did a lot of the hard work, heavy lifting here. So when it gets to the technical details, I'm going to hand it over to him. All right, so just a few slides about Branch. The company, as I mentioned, we were founded in 2014. We have about 250 employees worldwide, about 65 engineers right now. And I'll talk about the product in a minute, but we have about 45,000 apps using our core platform right now. We're located down in Redwood City, so we just took a lift up here a couple minutes ago. But we have 12 offices around the world. And we've been using AWS since day one. Right now, we have about 1,000 instances deployed across 2 different regions. So we've seen a lot of crazy growth over 5 years, both organizationally and from an infrastructure perspective. If you've never heard of Branch, our core vision and our mission is to solve the mobile deep linking and attribution problem, create a seamless experience across mobile web, native apps, iOS and Android, and really try to make linking as simple as it was back in the web days. So if you've ever clicked on a link and it opened an app that you actually already had installed and actually went to the place you were expecting it to go, there's a good chance that that was Branch in the background. So about the links, these links appear in all sorts of different channels, whether it's ads, referrals, social, email, marketing campaigns, or just organic links on mobile websites. These Branch links are everywhere around the web. And this is really setting the context for the scalability challenges that we had. And just a couple, a smattering of logos. Some of the biggest companies and apps in the world are relying on our infrastructure for their linking. So when we talk about scale and when we talk about availability and reliability, we're not just talking about in the context of our infrastructure. We're talking about in the infrastructure of companies like Twitch, like Amazon. All of these big names are relying on our infrastructure right now. I think this is streamed on Twitch, so hopefully there was a link that was shared, and I hope that that link opened and there's several viewers online. Fingers crossed. All right, so let's talk about these scaling challenges. So what is in a link? We've seen millions and millions of links on the internet for years. They're really, really simple. I took the screenshot this morning from the Reddit homepage, but it really is composed of just a domain and the resource that you're trying to reference. This is a branch link, reddit.app.link, and they have branch links throughout their mobile web homepage because one of their objectives, like many of our customers, is to get a customer from the mobile web into the native app. And again, as I mentioned, branch solves this problem and makes this a seamless experience. But like Reddit, like many of our other customers, they're creating millions and millions of links on a day-to-day basis. So we're going to rewind back to 2017, and that's when we first started evaluating Dynamo. Back in 2017, we had about 4.5 billion transactions coming into our platform per day. We'd seen our customers create about 40 billion links in the short 3-4 year time period that our company had been created. Over 100 million links were being clicked on every day, whether it was the homepage of Reddit, homepage of Airbnb, or one of our many other customers. And our customers were generating about 100 million new links per day as well. All the while, we were maintaining a success rate of 99.99 and also a very low latency, roughly 250 milliseconds at the 99th percentile. So we had billions of links, we had hundreds of millions of people clicking on them, and we had an expectation that this would scale forever and that it would be fast and reliable. From an architecture perspective at the time, we were using a lot of EC2 instances. In particular, we were using a lot of i2 8XLs at the time. This was like a pretty big and beefy instance. We were using RDS, and I believe in Database Week this week, they covered a lot about introductory to RDS. We were using Postgres specifically. We'd solve some of our scaling challenges by sharding Postgres databases. And we were using Aerospike as a key value database, which is a very high performant, low latency, clustered key value database, and a little bit of Redis. And lastly, our infrastructure was starting to evolve to the typical microservices or service-oriented architecture that a lot of companies in this phase go through. And we'll talk a little bit about that later on as well. But not just scaling the infrastructure, we had a lot of organizational scaling challenges too. And this factored into our decision making. So we only had about 30 engineers keeping this entire platform online. We had very limited engineering time for core platform investments. At this key growth phase of our company, we were 3 years old. Product market fit is crucial. Building new features, iterating on features, onboarding new customers was priority number one. And when you have 30 engineers, it's hard to justify re-engineering a data store or swapping out the database. So this is one of the biggest challenges that I faced as the engineering director at the time. So what was that immediate problem, right? So it's 2017. The platform's humming along. Costs were climbing. Operational burden was mounting. We had a very small ops team. We had a database that was growing by hundreds of millions of records per day. And we had an organic growth of 100% year over year, and we weren't expecting that to slow down anytime soon. So we were very quickly approaching a cliff where we knew that we would run out of capacity no matter how much money we threw at the problem. And we knew that we were going to have to solve this problem. It wasn't going to take a week. It wasn't going to take a month. We had to plan now. So some of the business requirements that we were faced with, this solution could incur zero downtime. We couldn't tell 40,000 customers that their links and their integration was going to break for 6 months while we swapped out the data store. We couldn't change the product or the API contracts because these integrations were live, they were deployed. We had to offer the same SLAs that we were already offering to our customers, namely low latency, high availability. And the cost for whatever solution we moved to needed to be ideally an order of magnitude cheaper than what we were currently deployed on. If I proposed a solution that was 50% cheaper, given the cost to actually implement it, it wouldn't necessarily justify. If it was 30% cheaper or maybe 60% cheaper, still not necessarily the case. I was looking for something that was going to be an order of magnitude cheaper.
All right, so now we get into the technical requirements. So this is kind of where the engineering team came in. The first and foremost requirement was minimal DevOps overhead. We had kind of one engineer that was dedicated to working with our Aerospec cluster, and it was taking almost all of his time. So that was something we were looking for, something we wouldn't have to pay attention to. Also, scalability was important. So as Ian mentioned, the 100% year-over-year growth was something we had to prepare for. Reliability and durability, standard things we require from a database. Like we can't have downtime, and we can't have links disappearing. So those are important to us as well. So our specific use case with links, there are a few caveats. So what we really cared about was reads. Reads need to be lightning fast, because that was the latency that the customer was exposed to. So when you click a link, you get redirected. That's a read, right? We have to read that link and figure out, oh, how do we redirect you? So that was something we were looking for. Random access was important because any link could be clicked at any time. We can't have slow links and fast links. We needed a simple key value data set because that's how our data was structured already. So we needed to stay in kind of the same structure. Our objects were kind of a fixed size, roughly. So links were around 1K each. We had some outliers, but a majority of them were around 1K. It was just redirection data and a couple of other IDs in there. Updates were very infrequent, so writes were less important to us. Not that they were just completely not important. They were just, we could incur some latency there. We weren't that worried about slower writes. And we didn't have a need to do any scans or range queries on links because they were just keyed by one ID.
So Ryan mentioned a lot of the specific challenges that we faced, and I wanted to call it out because it was super important to our decision making on how and why we picked this particular tool. Every company and every use case is going to be different. We spent a lot of time figuring out what criteria were actually important for us. And then we had to actually start evaluating, well, what are our options? So we created an evaluation framework, a matrix, to determine what data store are we actually going to move to. Some of the dimensions that we actually measured this against were things like, is this open source? Is there an open source community around it? What does the community support look like? What's the consistency model of the database? Things like what language support does it have? We have a lot of JVM-based services in our infrastructure. What was the existing expertise within our small engineering organization? Was there a path to multi-region, multi-data centers? And things like secondary indexes, efficient scans, and again, maintainability. There's a lot of options out there. We evaluated a lot of them. This is just a short list of the databases that we actually looked at. We didn't do a POC and deploy every single one of these. This would have been a little bit crazy. But we evaluated a lot of options because we wanted to make sure that we were making the right choice. This was a huge decision. This was a company make or break decision. So we didn't take the decision lightly. In fact, one of the decisions that we considered, and I've seen a lot of small startups at our size or even bigger consider, we considered building our own key value database that was backed by Dynamo and S3. When we looked at those optimization function criteria, we explored the idea of what would be the database to be the absolute cheapest possible to store hundreds of billions of links. So we whipped up a design, and we came up with this very interesting multi-tiered cascading aging out data into S3, IAS3, and then Glacier, and then we can store infinite links in there, and it would cost us like $50 a month. That's great. But it was really, really complex, and the idea of having 9 different S3 tables and a Dynamo table and a Java interface, and then ops has to expire data every month was not super palatable to anybody in the organization. We didn't do that. And this is kind of a snapshot of what, as we were nearing the end of the decision process, looked like, where we had to measure up all of our options and then say, OK, well, what is the most likely success criteria here? We could keep our current data store and then keep throwing logs on the fire. We could build our own, which I think is the column that has the most X's, and we quickly dismissed that idea. Yeah. There was a lot of really great key value database solutions out there that we could have moved to and deployed. But DynamoDB seemed like a very palatable option. We didn't have the domain expertise, so there was a risk there. And moving to any kind of new technology inherently introduces some risks, which we acknowledged but embraced. So again, for me, this was a crucial decision. This was potentially a billion-dollar decision. We didn't have that much time to make the choice because we knew it was going to take a lot of work to actually execute. And we really had one shot at this. I think that this was, for me, one of the hardest decisions that I had to help support and get the support of the team for in my role. And I'm glad that it worked out. Otherwise, I probably wouldn't be here speaking about it. But of course, we're sharing some of these lessons with you all today. But yeah, we had one shot, and we said, let's do this. Let's move to DynamoDB. Let's give this a shot. Ryan's going to talk about what that journey looked like.
Sure. Yeah, so I'll kind of just walk you through our process of creating a table and integrating it into our application, and show you how easy it was for us, considering we had zero experience with Dynamo beforehand. So first, let's just dive into what DynamoDB is. It's Amazon's fully managed key value store, and it had a bunch of features that we were really looking for. So auto-scaling was a big one. So I mentioned we didn't want to look at it ever, and that's what auto-scaling kind of should allow us to do. TTLs were nice because we have a feature where we expire links, so this would make that really, really easy. We wouldn't have to manually TTL them out ourselves. Point-in-time recovery, predictable cost growth. Those are features that a lot of databases have, but for predictable cost growth, DynamoDB has like a cost predictor, and it shows you the price as soon as you enter your requested resources on the site. So that was really nice. And increasing integrated caching and observability is something I'll get into later on. So this diagram shows our initial schema, so pre-Dynamo. What you really need to get from this diagram is that our links were keyed by link ID. So as Ian showed in a previous slide, links are composed of a domain and an alias. And in most cases, that alias is an encoded link ID. So we just decode that ID and look up the link by ID. We also have a feature where you can have vanity links, where the alias is a custom string. So you can have your domain / foo, and that would be a vanity link, because you get to pick the string that the link is aliased by. So for link lookups, our primary index was link ID. So when we had an alias link and we needed to resolve it, we had to do 2 hops, because we had a secondary index of link alias to link ID. But what we realized is that we could drastically simplify this flow by just having links keyed by domain plus alias, because even those encoded link ID links, they're still lookupable by domain plus alias, because it's just that the alias in this case is an encoded link ID. So if we go on to the next slide, you can kind of see our Dynamo architecture that we kind of inverted the indices. So now instead of link ID being the primary index, domain plus alias is. So this is really great because our migration to Dynamo gave us the opportunity to make this change and optimize our read path significantly. So for a majority of links, we only need to do 1 hop. And for those cases where we still needed to do link ID lookups, which were kind of internal use cases for the most part, they require 2 hops, but we were willing to make that sacrifice because it wasn't affecting our customers. In most cases, our customers would see increased performance because all links, resolution-wise, should take only 1 lookup. So this is just the create table UI, just to show how simple it is to create a table in DynamoDB. You just specify the table name and the attribute for your primary key, and you hit create. And it already comes with a bunch of great features out of the box, like auto-scaling, encryption at rest, which is great for compliance. Yeah, that's basically it. So in our application, when defining the schema, you don't define the Dynamo schema when you create the table. You define it in your application. So this kind of allowed us to define our schema as code. So this is the Java version of that. You can kind of see that all we really had to do was take our link class, which is this link item class, and add the annotations provided to us by the DynamoDB library in Java. So all these add DynamoDB attribute with attribute name, it just mapping an attribute and a class to a given DynamoDB column. So app ID would be A, and data in this case would be J. So another thing that we used a lot was the DynamoDB console UI allows you to look at items in through the UI and see the objects directly without having to query it yourself. So this was really useful because there's a lot of people with, like, you don't need to write scripts. You don't need people that were non-technical were able to go into the console and view links directly in their raw form. So this is an example of a simplified raw link. So these are not all the fields, but we just mocked one up. And people could go in and edit links directly. So for instance, if we got a ticket in for some, like a link deletion or something similar, you wouldn't need someone technical to do that. You could just go into the UI, look at the link, see what exactly is wrong with it, and modify it without any code at all. So this was a really nice feature that we used a lot, especially when we were debugging during our migration. And this is an example of using the Java client library that Amazon provides. It's really, really simple. So put item request is a class that you can put an item onto. And another nice feature was condition expressions, which are just conditional writes. And that attribute not exist expression means that the write would fail if that key exists. So U is the primary key, and if the specified U in the item exists, the write would fail. So this can get a lot more complex. Like for instance, for expiring links, you can specify that the expiry on the link is less than the current time, and do expiring links that way. And it's a feature that we leverage a lot for a lot of our linking features. So before we get into the migration, something that I'd like to highlight is how having a service-oriented architecture allowed us to do this migration a lot smoothly than it should have been. So at Branch, we kind of have a separation of concerns where we have lower-level services that product services consume. So we have a link service that all it does is it's a dumb service that serves links. It lets you create links, read links, and that's it. And other services call link servers to retrieve links or modify links and stuff like that. So it's kind of a data access layer. So what this allowed us to do during the migration was make a change in one service and iterate on that one service quickly without having to make changes anywhere else. So for upstream consumers, it was transparent. They didn't even know the database was changing under them. So that made it really, really easy for us and our team to do this migration without upsetting anyone. So.
Yeah, I'll also call out that organizationally, again, this was 3 years into our fast-growing company's history. This separation of concerns, the architectural patterns that we started seeing in our infrastructure, of course, mirrored the organizational structure that was building it. And it was crucial that our product and engineering teams were executing and delivering on new features and not being distracted necessarily by these core scalability challenges. Similarly, below this dotted line, we had our platform and infrastructure team that, of course, was very interested and wanted to support the product development, but we had them focus on these core scalability challenges. Both teams were executing in parallel. Again, it was a 30-person team, and we were shipping a ton of features every week, but this both SOA, architectural pattern, as well as organizational split allowed us to achieve both of these goals.
So for the migration, the main requirement was we need to do it live. So as we said earlier, we couldn't have any downtime for links. It just wasn't acceptable. So we need to, at the same time, while links were being served out of our old data store, ensure that our new data store was working and nothing was broken before we cut it off. So the way we did this was kind of a three-stage approach. First, we started off with dual writes, where at our link service, we wrote links when they would have been written normally to both data stores. So we wrote it to our old data store and DynamoDB. And we didn't serve any links from DynamoDB. So this allowed us to do a lot of early debugging and kind of POC Dynamo because it was getting our full production write traffic without any consequences to us because it was happening asynchronously. So that was a really big win for us. We found a lot of issues during this time and fixed a lot of bugs. But without dual writes, I think it would have been a lot worse if we had issues writing links to Dynamo. So after dual writes, we also started to do dual reads, which meant that when someone tried to resolve a link, we would try to find it in Dynamo. If we didn't, or if something went wrong, we would still have the opportunity to fall back to our old data store, which was still there and still being used as normal. So in the next slide, we kind of go through the timeline. So in the red, you can kind of see our old data store and how we started off with dual writes first with our full production 2K write per second traffic. And after dual writes was turned on, it provided us with like kind of a hard time, like a point in time at which we only need to migrate links before that point, because links after that point should have been migrated through the normal production write process if nothing went wrong. So once dual write started, we started to focus on the migration, which in later slides you'll see how much work that took. But once the migration was in place, we were able to start dual reads in the middle of it, because we had a metric that was able to track what percentage of links we successfully served from the new data store, being Dynamo, and it gave us a really good insight into like how far along the migration was, because as that metric trended up to 100%, we could tell like, oh, do we have all the links? Like, are links actually working from DynamoDB or not?
Yeah, and as Ryan mentioned, this dual read, dual write path allowed us to POC a new data store at effectively whatever percentage of production traffic we wanted. We were able to POC the write path, which again at the time was about 2,000 writes per second. And we were able to POC the read path, do latency evaluations to figure out what kind of scalability metrics we can see. Again, it was about 2,000 reads per second on the Dynamo side. And all the while, in parallel, while we were doing the dual reads and the dual writes, we were simultaneously migrating 40 billion links from one data store to another.
So yeah, so this is kind of like one of my favorite graphs. It shows the migration process. So so the blue line is kind of the write capacity we have provisioned. So in Dynamo, you specify how much capacity you want, and you pay for that. And the orange line is kind of how much is actually being used. So in an ideal world, you would use 100% of what you provision because you're paying for it anyway. So you can kind of see here that steady state low constant level is the production traffic of 2,000-ish writes per second. And these like huge spikes up to like almost 100K are the migration taking place. And the fact that we can do this, it was really amazing to kind of our team, because we were able to scale up and down like 50x with no questions asked. So this allowed us to migrate at our own pace. And like, if we were to do this with another data store, our ops team would have to scale up the new data store in 50x in order for us to complete the migration in the same amount of time. And as Ian mentioned many times, time was kind of an important factor here. We need to get off the old data store as fast as possible, and Dynamo gave us the way to do that with auto scaling. Yeah, this is also a cool graph. This is the percentage served from the new data store near the tail end of the migration. So you can kind of see it's at like 98%, and it's trending all the way up to almost 1. And this is kind of when we call it quits. We're like, yeah, it's good enough. It's 5 nines. It's higher than our service, our SR. So we had all the links. So now getting into the DevOps part of DynamoDB, this was really easy to set up. They have CloudWatch and alerting built in, so we kind of got a lot of that for free. And this graph at the bottom is kind of our traffic now. So the orange line again is provisioned, and the blue is consumed. And we set a buffer of like 30%, so we always want to be over provisioned 30% to like handle any insane spikes in traffic, because it does take a few minutes to scale up and down when the traffic changes. So you can see our traffic is very sinusoidal, and it really helps us with like cost-wise and also like just ops-wise. Because when there is a burst in traffic, usually we don't even know, because Dynamo scales up itself so quickly. So another useful tool that Dynamo provides is DAX, which is kind of its integrated caching solution. So at the beginning, I mentioned that links, we care about link read latency. That's kind of the customer-facing latency. And another interesting pattern that links have is that there are usually very few hot links. So like when someone runs an ad campaign or like some link gets popular on Reddit, an individual link gets a lot of clicks. So caching was an obvious solution for this, and DAX made it so easy to add to Dynamo. So to add DAX to our DynamoDB, it was almost a one-click process, but the main benefit of it was that our code didn't change at all. You just swap out the jar. It's fully DynamoDB. The DAX is fully DynamoDB compatible, and it just worked. So it also provided a couple other benefits like multi-AZ. So you can see like DAX nodes can run in multiple AZs. which gives you kind of better uptime and reliability. And that graph on the right is our cache hit rate. So roughly like 80% of links right now are being served from DAX, which makes them faster because it's being served from an in-memory cached, and cheaper for us because we don't pay for that read capacity we would have otherwise had to pay for because we're not touching the DynamoDB directly. And these are just a couple additional features that DynamoDB provides. So encryption at rest, really good for compliance. We kind of got that for free when they released it. Point-in-time backups, something that we don't use yet, but we're planning on using so that just in case something bad happens to our LinkDB and we need to restore it to a previous version, and global tables and secondary indexes, both features we don't take advantage of yet, but would may be useful in the future. Just a couple metrics from our production link database. Reads directly from the DB are served usually within 3 milliseconds at the 95th. Writes at 5 milliseconds. Cached reads from DAX, we don't have hard metrics on this. We just know it's faster than 1 millisecond. So that's really good considering that's what the users experience from the database. We have 60 terabytes of links and 75 billion objects. So roughly 1K, maybe a little bit less per link on average. And the scale ups, the fact that it can scale up to 50x in minutes was just amazing to us. And something like, if you contact Amazon during the migration, you can actually ask them to scale it up even more or faster. So it was nice to have that option too, in case we need to do some sort of a large scan on our data or some analytics. The option is there. So 1 year later, currently, we actually don't really think that much about our link database on the platform team. It's kind of it just works. It's one of the few databases that an application team owns because we don't have to do anything. So we're happy to own it. We haven't had any incidents. There are latency spikes occasionally, very occasionally, but majority of the time those are mitigated by having DAX there. So even though the DB sees a spike in latency, customers don't see it because the links are cached.
Yeah, so we tried to lay out a huge section for lessons learned a year later. We completed the migration, I think this week, 1 year ago. And the reality was, as Ryan mentioned, we barely ever touched Dynamo. Somewhat ironic for a tech talk today on DynamoDB, but after we concluded the migration, we were very fortunate to barely ever need to get involved. We love Dynamo. Dynamo is working, but we basically never need to think about Dynamo, which has been awesome. And from a success criteria perspective, as we mentioned at the beginning, little to no ops oversight was one of our requirements. And a year later, that's exactly what we got. When we need to make improvements, when we need to iterate on it, we dive in. But when we need to continue throwing production traffic at it, it just works and it just scales. And I think that is everything that you could ask for in a managed database. 1 year later, I think one of the biggest takeaways for me is the simplified cost modeling. So again, as you're growing and scaling your company, how you think about OpEx and CapEx is crucial. And I'll talk a little bit about TCO and how to calculate costs of a data store. But because we moved this entire cost center into Dynamo, it appears as basically one line item on your AWS bill, which from my perspective is great. It makes my life and my job a lot easier, even if it's not a ops or an application level kind of benefit. So I'm going to walk through some of the key takeaways that we learned from this experience. We talked a little bit about how we got there, the journey we took, as well as some of the technical considerations. I think having this clear evaluation framework for how to make a technology choice is crucial. It is very easy to get distracted by all of the options out there and perhaps pick a technology, whether it's a database or maybe a compute platform, that is really not relevant to your problem. Ryan spent a lot of time talking about the very specific nuances of how we use links, what we needed, what we didn't need. I saw a few people taking notes. That's great. But unless you're also making a mobile deep linking and attribution company, and if you are, let's talk afterwards, but unless you're making that exact use case, your use case will be different. So we had to enumerate what our important criteria were, and that's how we made a very objective, non-emotional decision on this technology choice. We talked about separation of concerns, both architecturally and organizationally. even at a small growing startup. I thought that ensuring we invested in the core scalability of our infrastructure, as well as enabling the product team to continue to ship and iterate that early in our company stage was pretty life or death. Because I think back to 2017, if I had told the product and eng team, stop what you're building for the next 6 months because we're all hands on deck migrating this data store, as a early stage startup, that would have been like near death. That would have been a disaster. And we were able to avoid that particular pitfall. Don't over-engineer your solutions. I intentionally shared that diagram of one of the options that we considered. I personally find database design and scalability very, very interesting, and I would love to design my own key value database. But I think the stakes were high, time was tough. As tempting as it was to ask Ryan, hey, your job for the next 6 months is to build something better than one of the 50 key value stores that I enumerated, I think that would have been a terrible decision on my part. I probably wouldn't have been standing here right now and speaking to you about our journey. But there's a lot of simplicity in picking a tool like Dynamo, and this is one of the choices that we made. So the true TCO, or the total cost of ownership, and this is usually one of the cost evaluation frameworks that you're going to use when you're picking a piece of technology, has a lot of hidden costs. It would have been very convenient for me to just say, OK, the cost of option 1 is how much EC2 hardware I'm going to need in order to deploy it. But the reality when you're doing this A/B comparison is how much EC2 hardware do you need? How much EBS and disk volumes do you need? What's the data transfer in and out of that zone or that network? What are the salaries of the engineers that are going to build it, maintain it, and support it? Are you going to be using any particular enterprise software that might require licensing? And of course, as I mentioned earlier, what's the opportunity cost to your company when you're building this new database or maintaining a new database when you should be shipping and building new features? I referenced the billing of Dynamo, and it simplified the cost modeling for us. The cost modeling tool that we used when we planned this out mirrored exactly what we ended up seeing when we went full-scale production. When we did the migration, we knew there was going to be bursts of high volume of throughput, and that's the cost that we saw. Now that we're at production scale and it's smooth and humming along, it's very, very predictable. And again, depending on how big your deployment is on Amazon right now, if it's like one page, I'm very envious of you. But if you're operating at our scale, your AWS bill might be a nice long 100-page novel. But seeing a one-line item of Dynamo storage makes, again, my life easier and cost modeling a lot easier. Don't move everything at once. This talk about Dynamo, a lot of it was about migrations. I've seen a lot of companies fall into the pitfall of saying, we're moving to a new data store. And the first thing they do is plan out how they're going to move everything. We have a ton of different data models within our infrastructure. Links, as Ryan spent the talk discussing, was just one of them. As a startup, again, our data model and our schema was constantly evolving. As we started to see product market fit, certain data models and certain schemas started to converge to, this is clearly how links are going to work today, and this is probably how they're going to work in a few years from now. So this was the clear candidate that we chose to move into a new data store. And it was very convenient. It was a very seamless process, as we discussed. But if we had tried to pick a data store that would have fit every single data model that we had, it would have been near impossible, and we would have had option paralysis. We wouldn't have made a decision, and of course, that would have been pretty terrible. So, don't move everything at once. Pick what you actually need to move. Pick what's important for your company. And then planning. I've gotten different heuristics from different founders and CTOs about big technology shifts, and it's not just isolated to data migrations. These projects are going to take 6+ months. So you have to plan accordingly. It seems like even something like what Ryan described was very painless. It was very seamless. But it isn't just the development time. I mean, how many sprints or how long did you actually spend coding and integrating it?
I think we just stopped doing sprints. We're just like, we're doing Dynamo again this week.
Yeah.
Yeah.
So the coding part and the development part was actually pretty straightforward. But the evaluation, the cost modeling, the migration, the testing and validation, and then, of course, making sure that things scaled and hummed along. So when it baked into production, this was over about a 6-month period. So it's not going to happen overnight. Maybe if you're at a smaller scale and you're able to pull an all-nighter on a weekend and swap out your database, like, great. But if you don't have that luxury, or if you don't have the luxury of telling your customers, hey, we're going to be down for a couple days, just chill while we kind of swap out the data store, you have to plan accordingly. I shared a graph, a very scary graph earlier on. Usually up and to the right is the graph that all startups want to see. But when that's a cost function or when that's a capacity function and you have a clear red line and you can just eyeball on the chart, OK, in 5 months we're going to hit a brick wall, maybe it'll be too late. So I think that we made this decision barely at the last minute, but we got it done and we got it in there. And then the last takeaway before we go to questions, in hypergrowth mode, realistically, the ideal technology solution might only last you 2 years. And this might seem counterintuitive because when we're about to migrate off one data store to another, ideally you'd say, let's never do this again. But the reality is it's impossible to predict what our use case is going to be as we're growing at an exponential rate. I'm hoping a year later, we don't see any reason why we're going to have to change this. But as you evaluate some of these technology decisions, avoid the pitfall of saying, I'm going to build and design something, and I'm never going to have to look at it again. Because the reality is, a month later, you might get a new customer that completely violates or breaks all of the principles or assumptions that you originally had. Or maybe a year and a half later, that huge, massive project that you invested in that was this golden, perfect data store or compute framework or MVC framework or whatever it was, the customers didn't end up using that product and they used something else. And that investment was kind of a waste. So at this growth phase, be very pragmatic that the solution that you are building, it needs to get you through the next couple of years. But you're going to have to reevaluate these decisions every year or every other year. Cool. So I hope that you got an overview of how our company scaled, how we use Dynamo. The talk was entitled Scaling from Zero to Billions because it covered both the zero traffic when we first started to the billions of links and clicks and transactions that we're serving today. We're a 5-year-old company. We're down in Redwood City. We're very fortunate to have gone through this whole experience. And if you have any questions, we'd be happy to take them now. And of course, my one obligatory slide, if this stuff is interesting to you and you want to help us out, we're actively hiring. Feel free to give me an email or come talk to me later on. But thank you, everybody. This has been great. So thank you very much. Cool. Yeah, so we'll go to questions. Yep.
Overall time frame it took complete migration. First question. Second is,
Yep.
Was there any downtime?
Sure. So I'll repeat the question for the stream viewers. First question, and let me know if I mischaracterize it. One was, what was the beginning to end time frame for this migration? Second question was there any downtime? When we were preparing these slides, we saw technical specs that dated back to early 2017. So we were talking about it for a while, but waiting for the right time to actually execute on it. I think when we finally made the decision to write the first line of code or set up that first Dynamo database to when we showed that we had 5 or 6 or 7 nines of accuracy, I want to say it was about 6 to 7 months end to end.
Something like that, 5 to 6, 5 to 6 months.
And a large chunk of that was just the data validation because we didn't want to just turn it off until we were confident that everything was there. So first line of code to we were no longer writing to or thinking about our old data store, I believe it was around 6 to 7 months. The amount of time we actually spent coding and updating our clients was probably in the order of weeks, maybe a bit less. But writing tooling and writing jobs that can lift and move billions of records from one place to another takes a lot of time as well. Second question was there any downtime? No, I would have been very upset if there was any downtime. Our customers would have been upset. Because we had that dual write mode, we did have a very safe fallback mechanism. But again, one of the criteria that I laid out at the beginning of this project was like no downtime, and we were able to satisfy that. Yep. Thank you.
On the migration,
Sure. I'll repeat the question, then you
Sure.
got this one. So the question was, during the migration, when we were hitting it with like 100,000 writes per second, how did we handle throttles? How did we handle retries and any errors upon write?
Yeah, so the way we did this was, because we had that metric to show like the 99.9s, like how much was being served out of DynamoDB, we also had a mechanism to determine like which links were missing. So like every couple of days, like throttles would happen, right, like occasionally. And when we did find missing links, our application would log them, and we'd aggregate them and then migrate those links. So over and over until we got them all. So it wasn't an ideal solution, but it worked for the time frame. There'll definitely be a way to mitigate those throttles. Like for instance, I think during that time, DynamoDB was a bit newer, and the throttles were a lot more were a lot worse. Now we barely see any in production, which I think that has definitely been fixed. So these throttles.
Yeah, the other component was that when we were doing our regular write volume at, let's say, 2,000 to 3,000 writes per second, that was the provision capacity that we had. And then when we knew we were going to crank up the migration, I think we called AWS and said, hey, can we bump it up to like 200,000 provision writes? And they were like, okay.
Yeah.
And then we just like let it rip. So the throttles are really supposed to come when you are going over your reserve capacity. So we were able to scale up like by order of magnitudes, 2 order of magnitudes, just blast it and then scale it back down. Yeah. Question over here?
So I missed the first part of the session.
Sure.
You migrated from what kind of data store, the relational data store, into this one.
Yep.
The second question is, during the migration, what kind of measures you put in place to guarantee the data in the DynamoDB is consistent with your source?
Sure. So the question was, what kind of data store did we move from before in Dynamo? Second question was, how did we make sure all the data was there? So the first one was we were using a key value database. It was a distributed key value data store. It was a combination of a little bit of Postgres. We were using Aerospike, which is a clustered key value database that we were managing, and a little bit of Redis, and then we moved it into Dynamo. The second question around how did we know we moved everything? We had a lot of different evaluation criteria. What it boiled down to for us was on the read path, what was the success rate of us finding the link that the customer was looking for. And we would track, when we started, we would try to read it from the primary, we would try to read it from Dynamo, and then when we had nothing in Dynamo, it was 0% success rate. And then over the migration, that inched up. And eventually, near the end of the migration, when we hit 99.9999% accuracy, we said that we were confident with the migration.
So you don't have the requirement of saying, hey, I need to make sure every data entry in Dynamo is back there. And there's not more, not less.
Yeah, so again, the question was like, we didn't have the requirement that we had like, let's say 100 nines of accuracy. The nature of our data, and again, this was one of the unique use cases for us that we benefited from, was while we treat links as absolutely crucial for our product offering, our product also has intelligent defaults. So if there was, let's say, 1 out of the 50 billion links missing, the link would default to the company's homepage or a default redirect. Because we had that failback mechanism, and it wasn't, say, let's say, ledger records on a, like for a Bitcoin company or, bank records, which are crucial. This was a constraint that we were able to relax. And that's also why when we hit 7 nines of accuracy, I was confident moving on.
Yeah. Additionally, in our application, when we did do the dual reads, we actually did have some logic where we took hashes of linked data and compared them. And if they were different, we're like, oh, log this. Why is it different? And we were able to find a lot of bugs like that. But we still did not need like every single individual one.
Have you ever had a requirement to say, I have a million data entries in my Dynamo. I need to really know what they are, slice it and dice it, and then all the stuff. Because that's usually the common task for relational database.
Yep.
So because we actually, in our business, we have 2 data stores.
Yep.
One of them is a relational database.
Yep.
It's Postgres.
Sure.
Like this.
Sure.
Another one is Dynamo. So Dynamo actually is sort of more like sort of a cache.
Yeah.
So we want to make sure their data is exactly the same.
Yeah, so the question was, do we ever have the use cases where we do need to do slicing and dicing? Again, the particular use case we were solving was for that read-write path for our online service. We do have a lot of analytics and metrics and different data stores for those types of use cases separately from Dynamo. Yeah, we didn't try to like re-architect and re-engineer a relational database on top of Dynamo. That would have been a bit of an over-engineering problem. Cool. Any other questions from the audience? One at the back? Yep. Question was, when we contacted AWS to increase our throughput, did it impact cost? It did, but as we had expected, because of the nature of how provisioned capacity works, we said we want this much capacity, and Amazon enabled it, or you can automatically set it up, and that's effectively what you're getting billed against, and then we use that capacity. And the second we were done with our migrations, we scaled it back down. So our current run rate is like, gives us 30% headroom, because that works for our traffic pattern. But when we reached out to Amazon, we knew that, okay, this is going to take, this is going to cost some money, but that was part of the plan.
Yeah. So one of the main benefits of reaching out to them was it scales up faster. Otherwise, it will take like a couple hours, I think, to scale up to that rate. But contacting them just makes it go faster. But you still have to pay for the capacity. So.
Yep.
What technology came in second place or third place?
Yeah, so the question is, we did this huge evaluation. What technology came in second or third place? I would say that staying on our current infrastructure was one of the highest contenders, and I think that would be the case for a lot of companies that are deciding, should we move? And that was about forecasting out what does the next 2 years look like from a cost perspective. That probably would have been number 2. I'd say number 3, we were really close to building our own key value database, and I'm really glad that we didn't. Maybe it would have been a really interesting tech talk at a different conference, but that was a possibility. And to be fair, that was the original plan was to build it on top of S3 because we wanted to spend like $1,000 a month for everything. That could have worked. I think our latency would have been a lot higher. But other than that, we had a lot of experience doing sharded Postgres, so that would have been an option. But I think that when we did this evaluation, it was a pretty clear contender for us. Cool. We have a few more minutes. Yeah.
You touched upon earlier about the data life cycle, the planning, but do you have the data life cycle in place or planning, and what kind of cost reduction are you looking to do that?
Yeah, so the question was about the data lifecycle for this particular migration. And just to clarify, do you mean, given how the product expectations work, do we have the ability to retire certain data sets or delete certain data sets? Is that the question?
And using the lower cost stream.
Got it. Yeah. So yeah, we actually, and when we were evaluating our options, we tried to figure out, well, what are different ways that we can tier the data? Because perhaps somebody that clicks on a link or creates a link today, like 3 years from now, they're probably not going to click it again. But we've made the promise that should they want to do it, we're gonna have that for them. It was a factor that we considered, but when we modeled out the actual core storage cost of Dynamo, it was one of those problems that we said, we're going to actually solve this problem at a later time. So our table has grown immensely. Dynamo has scaled horizontally. Our costs have grown, but at a very manageable pace. I do think about that a lot because it bugs me that we might have an aging piece of data that's sitting relatively hot in a very high-end database. But from a cost perspective and from the priorities of everything else our company is working on, I said we'll revisit this problem at another time. Yeah. But now I'm thinking about it again, and I'm going to probably go home and like, well, what if we age out the data into S3 and Dynamo streams and all of these other options? Glacier, yeah. But no, we didn't do that yet. Yes?
What are you guys thinking about switching to on-demand
For Dynamo specifically?
versus the provision?
So the question was, are we thinking about switching to on-demand for a capacity perspective to potentially optimize our billing and our costs? Is that correct?
So yeah, so this is something I think we've looked into recently. We only became aware of it like a couple weeks ago, I think. And At the moment, I think that provision capacity is still cheaper because on-demand is really good for spiky workloads, and ours are just so predictable that auto-scaling works really well right now. Yeah.
Yeah, so just to add a bit more context there, and I'm not an expert on the on-demand billing, but the model of doing provision capacity where you say, this is how much I want, whether you use it or not, you're going to get billed for it, and then automatically scale up as I need it, and you get billed at one rate, and then the on-demand says, just bill me for exactly what I use, so that capacity equation, you don't have to worry about, but the billing is a little bit higher because they're doing a bit more work for you. Because our traffic pattern is so kind of like it's the sinusoidal wave of the internet, it's like the pulse of the internet, we're able to pretty easily predict what we need to provision at. And I think 30%, 40% headroom for most services is actually pretty low, but because we can predict our traffic so well, it works just fine for us. Yeah.
I'm pretty new to DynamoDB, so my basic question is, so you have DynamoDB, but what kind of storage tiers are you using? Is it like S3? Where exactly?
Sure. So,
And the second question
Yep.
is, by default, when I'm using any product within Amazon, we have a font particular region. Is it like split across different regions?
Sure. Cool. So first question was just, we're learning about Dynamo today. Is there a different underlying store that's being leveraged? Second one was, what are the multi-region capabilities of this? So for the first one, Dynamo is the core storage. So the data is stored in DynamoDB. Yeah, and I'm sure there'd be an Amazon engineer or a Dynamo engineer that can tell you a little bit more about what's going on under the hood there. But that was, again, one of our criteria was like, we want this opaque black box to warehouse all of our core hot link data, and that worked perfectly. Yeah, we have a data lake and we have a big data store for different type of operations, but for this particular use case, the links go into DynamoDB and they're stored somewhere in a data center in Northern California or whichever region we're deployed in. The second question on the regional support, our implementation did not take advantage of a feature that they have called global tables, where you do have globally synced multi-region support for Dynamo, so you could do a write and it would automatically replicate to all regions. It was not a use case that we had at the time, although it's a nice capability that is good that it's mostly like a couple clicks away from enabling.
Yeah. It is eventual consistent replication, but yeah, something we are considering.
Cool. And I think we have like one more question before these guys yank us off the stage. Yeah?
My question is, you say you use different databases for different things. So do you separate your clean data out of DynamoDB? Like exactly, you're only doing links in DynamoDB then?
So the question was, because we mentioned a lot of different data stores, do we only put links in DynamoDB? We, over the last year, have introduced a couple more use cases for Dynamo. I believe we're using Dynamo also for some of our like outer gateway layer rate limiting. We use it. We also use Dynamo internally for some of our cryptographic key session management. But that's like for an internal use case. Our user data is stored in other data stores like Postgres, like AirSpike, which is still like a hyper efficient, fast, performant key value store. But yeah, it's a mix of data stores. And that one slide that I'll emphasize where I said, don't move everything, it was very tempting to say, like, let's go all in and put everything in there, but it wouldn't have made any sense for us.
So they kind of, what was the deciding factor on what you put there?
Yeah, so the question was, what was the deciding factor of what did go in and what didn't? It was really about what core business object was scaling at a rate that wasn't manageable given the current implementation, and what core business object did we feel confident we could predict what the schema, what the needs were 2 years out, and it was honed in on this one particular data set. And given the service-oriented architecture that we'd moved to, it made it pretty easy for us to actually execute on this plan without having to like mangle every service and every piece of code in our infrastructure. Yeah. So our core user table was still in Postgres. We didn't have to touch our big data pipeline. It was just this one data set. It's good to go, and let's move it out.
You have everything running in AWS, and you kind of spread them out to different systems that you want. Like, do you spread things elsewhere as well?
Right. Cool. So last question was, is everything in AWS? Right now, our whole deployment is in AWS. Yeah. Cool. So I think that's time, and we're going to hang out afterwards if you want to talk about this stuff or anything else. But again, thank you everybody for your time.